Problem number 6. A wire 2.3 meter long carries a current of 13 ampere and makes an angle of 35 degree with a uniform magnetic field of magnitude B equal to 1.5 Tesla. Calculate the magnetic force on the wire. So in this question, we are going to find the magnetic force on the wire with the information of the length of the wire as well as the current in the wire. Also, this is kept in the uniform magnetic field of an angle 35 degree, and the uniform magnetic field takes the value of 1.5 Tesla. So first of all, let's rewrite the given first. So the length of the wire is given here, which is 2.3 meter long, and the current in the wire I value is 13 ampere, and the angle theta is 35 degree. The uniform magnetic field value is 1.5 Tesla. So in the theory, we studied the rule for the magnetic force calculation based on the length of the wire and the current in the wire with the help of this magnetic field. So what is the formula? FB. Here FB stands for the magnetic force. So FB, which is equal to ILB sine theta. So this is the rule for calculating the magnetic force. So now I'm going to substitute all the values in this formula. So the value of the current I is 13 ampere, and the length of the wire is 2.3 meter, and the magnetic field, the uniform magnetic field value is 1.5 Tesla multiplied by sine of 35 degree. So here I got the answer for the magnetic force on the wire is 25.72 Newton. So this is the answer